All right, chaps, we are nearing the end of integration. We only have, I think, this lesson and one more. Then we're done, which is fantastic. This lesson is mainly a revision, but we will learn a few things. And we're going to use integration to calculate area under the graph. Just want to make sure you guys see everything you need to see. I think so. Okay. So let's start with something we've been doing a lot for quite a while, finding what we call the indefinite integral of this function. X, we'll write that function y equal x squared plus 1. So by now, I think it should be very easy for you to realize that it's x cubed over 3 plus x plus c. Okay? That's constant. Now I want us to think, okay, but what does it mean? What does it mean really to find the integral? Because remember, we started calculus with derivative. And we say if I take the derivative of a certain function, dy to dx, then if I draw a picture, let's draw a picture of a graph of this function, x squared plus 1, just teaching that to my grade 10. It's a parabola, isn't it? A parabola, okay, like this. This is 1. So what is the derivative? Dy to dx is basically the gradient of y. Okay, it's a function of y in this case, right? And the derivative of that will be what, 2x, and that is going to be basically the value of the gradient in different places, in different x's. So the question is, what is the idea, or what's the meaning behind the integration of that? And I think you probably remember that what we started integration with this, with realizing that it's something to do, well, it is the area under the curve. Okay, so let me just set up something on the board and then we'll remind you that. Okay, so yeah, just a quick recap of where this integration came from. We actually were trying to ask ourselves, if I have, let's say, this function, y equal x squared plus 1, and I'm putting these edges, okay, between x equal minus 2 to 1, and I want to find out the area, okay, I want to find the area here. Now, the way to do it, what we said is, we'll divide it into little sections, we'll divide the x into little bits that we call delta x's, okay, and then we just made these little rectangles, something like that. And we said, well, I don't know exactly how to find out the area under the curve. That's going to be quite tricky, that area. But I know how to find the area of these set of rectangles, right? So the area was kind of, I'm saying not equal, but it was kind of equal, okay, to the sum of, let's call it from now, if you don't mind, f of x. Okay? So we basically did f of x, okay, f of x times delta x, okay, so f of x I, where do I write the I? Right at the bottom, f of x I times delta xi, okay, when I'm summing from x equal minus 2 all the way to x equal 1. So I divide it into those sections. In this case it was 1, 2, 3, 4, 5, 6. So I had 7 different xi's, okay? And every time I multiply, because why am I multiplying the f of xi? F of xi is the y value, so it's this bit, it's this bit, it's this bit. So I'm multiplying that height, okay, or that height. Let's say, all right, sorry. If I want to find the area, I'm going to have to calculate the area of this rectangle plus this rectangle plus this rectangle. What is the area of each rectangle? It's the y value, the f of x, times the width, which is delta x. So I'm multiplying the f of x1 times delta x plus f of x2 times delta x times f of x3 times delta x, and so on and so on and so on and so on. Why is it it's not exactly equal, it's kind of equal? Because you can see I've got the area of the rectangle is actually a little bit more or a little bit less, okay? It's not exactly the same, okay? It's not 100%. Here I'm actually calculating area a bit more. Here, it will be actually a little less. So then we said, how can we make this area as close as possible to the real area under the curve, And the answer was, let's make delta x smaller. Okay, so instead of having 6 rectangles, we go with maybe 600. That will be closer. Okay? How are we going to get the exact area? Well, we're going to get the exact area when we take the limit, the sum, when delta x approaches 0. When delta x approaches 0, okay, we've got a tiny skinny little rectangle, okay, and we're timing that skinny width, which is almost 0, by f of x, but I'm doing it infinite time, because as I'm making delta x smaller and smaller and smaller, then I'm making more and more rectangles. That sum actually becomes an infinite sum, which we call the Riemann sum, if you remember. Okay? In that case, that's actually the definition. By definition, I'm going to write 3 lines. That means that's the definition. That's the definition of the integral. F of x dx from x equal 1, or what was it, minus 2 in this case, to x equal 1. That's the definition of the integral. And the integral is therefore the area under the curve. And I'll add one more word for it. There's a difference between this kind of integral. I just want to see that you can see it. Yeah. There's a different kind of difference between this integral and that integral. Can you see that on this integral, I don't have numbers. I don't have the boundaries. Here I do. This one is called the indefinite integral, and this one is called the definite integral. All right? And I'm just going to clear, oh, I've got some space, so let's just do that. Let's find the indefinite integral of this specific function. This is for any function. But now I want to work with the the definite integral of this. So I'm going to write down from minus 2 to 1. And instead of f of x, we're working with x squared plus 1 dx. And what we said we do exactly the same thing as the indefinite. Okay? We're going to write x cubed plus x divided by 3. I'm not going to write the c. I'm not going to have the c. Okay? Yeah, but you know what? Let's write the c, and then you'll see that we actually don't need, you'll see that we don't need the c. So I'll write exactly the same thing, and then I'm going to get rid of this definite here, if you don't mind. I'm going to put that in brackets, and I will put this line, and I'm going to write x equal minus 2 and x equal 1. It's all stuff that we've done. We've done this, I'm just reminding you. Yeah, I'm not altering it, okay? So now how do we calculate? What does that mean? That means, I'm going to write it down here if you don't mind, okay? So that means now we're going to substitute the top value first minus the bottom value, okay? So we're going to write it. We're going to write 1 cubed divided by 3 plus 1 plus c, okay? Minus, in brackets, now I'm going to put the bottom value. So minus 2 cubed divided by 3 plus, I'll write minus 2 plus c. Okay? And then I'll need to just open it up. Okay? 1 cube, so I'll write down 1 third plus 1. Here I've got minus 2 cube is minus 8 over 3, so, but it's minus 8, so it's plus 8 over 3. You see, minus 8 over 3, so it's plus 8 over 3. This is minus 2, so it's plus 2, okay? And c minus c. The c cancel the c, okay? So now you see why we don't need the c. I could have erased that c, okay? We're never going to have to actually put the c in the definite integral. In the indefinite integral, we have a c, a constant that we don't know. It's not fixed. But when we're calculating area, we can't have that c. I mean, area is something fixed. We need to have an answer. What's the area under the curve? I don't know, 5, 5.2, 5 and a third. Needs to be something. I can't have a c there, okay? With the indefinite integral, we have flexibility, okay? So I just wrote that c once, and I'm not going to write it again because you can see that it cancels out. So from now on, let's just erase it as if it was never there. Never there. Okay? Get rid of it. Okay, so now I just need to find that, and that answer is 8 over 3 plus 1 over 3 is 9 over 3, which is 3. 3 plus 1 plus 2 is 6. I'm hoping I'm right. Olivia's not here to show me if I'm right or wrong. 9 over 3, we'll have to just go with that. Okay. So the area, I wasn't too far. The area under this graph between this graph and -2 and 1 is 6 units, whatever that units are. Okay, let's do some more examples. Okay, so our next example, we've got another parabola, 2x minus x squared, okay? And we want to find out the area between here, where x is 0, and 3. Now, you might be tempted, and let's just do that for the sake of it, okay? So, we're finding the area, so what we got to do, basically, is say, okay, from x, what does x equal here? Well, it's 0. 2x equals 3 of 2x minus x squared. Let's just do that. Let's just do that, okay? It's actually wrong. Maybe you can figure out why that is wrong, okay? But let's just do that. See what we get. So I'm going to get x squared minus x cubed over 3. Okay, that's just the indefinite integral. If it was just indefinite integral, I would say plus c, but I don't need it anymore. So I'm going to write down here, and I'm going to substitute for 0 and 3. Let's see what we get. So it's going to be 3 squared minus 3 cubed over 3. Just substituting 3. Minus, okay, putting 0 and everything, I don't need to do anything, right? It's just 0, it's minus 0, okay? So minus 0. What do we get here? 9 minus 27 over 3. Now, we're in a bit of trouble here. We're in a bit of trouble because what is 27 over 3? 27 over 3 is 9, isn't it? Okay, so it's actually 0. Now, how that area can be 0? Okay, so it's actually good that we went the wrong way first. Maybe you can think, why do we get 0? Clearly, this area is not 0. So what you got to remember is that the area, when we calculate the integral, the indefinite or the definite integral, we're getting an area, but if it's below the x-axis, it's a negative area. So I should have really clarified better and maybe write it down, okay? The definite integral is equal, indefinite integral of f of x, let's say, is the area between curve and x-axis. But if it's below the x-axis, it's negative area. Okay? So I've got to be careful. What are we asking? Are we asking for the area? We work with area. Area is not negative. But you can see that we've got two areas. The areas between the curve and the x-axis, there's two parts. There's where the curve is above the x-axis and where it's below. Dad's going to cut this bit here will be positive area. This bit is going to be negative area. And what we can see is that the overall area is 0. In fact, what we realize then, that these two areas are equal. Okay? So how do I find really? How should I find the real area? Because I'm not interested in area 0. The area is definitely not 0. Okay? So let's just erase that one. Okay? Okay? What I got to do is find out the area here. Find out the area there, turn it to plus, because this is going to be plus, and then add them up, okay? So let's do that, okay? So we're going to find, first of all, the area of 2x minus x squared from 0, well, I don't know what that is, but that is stuff that my grade 10 or maybe even my grade 9 can do, okay? That's just the x-intercept. So how do I find x-intercept? The y is 0, so we're going to write 0 equal 2x minus x squared, x 2 minus x equals 0. So we have two solutions for that. X equals 0, which we know it's going to cross here, and x equals 2. So, okay, so that's at 2. So it's going to go from 0 to 2. Okay, so that's this area. Okay, we need to do dx. So that's going to be the same thing, x squared minus x cubed over 3, but this time from 0, not to 3, but 0 to 2. So that's going to be 2 squared minus 2 cubed over 3, which is 4 minus 8 over 3. How much is that? Okay, so that will be 12 over 3, right? 12 over 3 is 4, so it will be 4 over 3. I hope so, okay? Now that's that area, okay? So this area here is 4 over 3. Now, actually we know now the answer, isn't it? Because we just realized that the whole, if we were foolish enough like I was and calculate the area from here to here, the definite integral, okay, we got 0. So as I said, the area here is equal to the area there. Okay? And if both these areas are the same, and we just found that it's 4 over 3, then that must be also 4 over 3. So altogether, the area will be 8 over 3. But let's just do that, because that's not always the case. It's not that when we split an area, the areas are always going to be exactly the same. So just let's calculate that as if we didn't know that these two areas are the same. So to finish it up, we need to go from 2 to 3, find a definite integral of the same curve. Okay? And that will be actually a good exercise to see that hopefully we're getting a negative 4 over 3, because it should be a negative area. Let's see. Okay, so we're going to write the same thing, x squared minus x cubed over 3. But this time, the boundaries are not from 0 to 2, they are from 2 to 3. Okay? And mind you, I'm not writing brackets here. You don't have to. That's understood. This thing is understood that you put in 3 and then you put minus 2. Okay? So we're going to write 3 squared minus 3 cubed over 3 minus, open brackets, don't forget these brackets, 2 squared minus 2 cubed over 3. Okay, here we've got 9. 3 cubed is 27 divided by 3 is 9. So that actually is 0. This business is 0. So minus, and here we've got, let's open brackets, 4 minus 8 over 3. Okay? So minus all we're going to have is 8 over 3 minus 4, which is exactly the opposite to what we had here, isn't it? Okay? That's, what is 8 over 3 over minus 4? It's 3. 8 minus 12. So it's minus 4 over 3. Okay, so it worked, okay? We can see that these areas are the same, but here we have a negative area, we have a positive area. More importantly for this question, what is the total area? Well, we need to turn him to positive. So the total area is going to be 4 over 3 plus 4 over 3, which is 8 over 3. Okay? I'll pause here. Okay, the third and the last example is to calculate the area between two functions, between two curves. So far, we just calculate the area between a curve and the x-axis, but now we have two graphs, two functions, a linear function and a parabola, and we want to find the area between them. Now, what I'm going to claim, I think if I ask you, okay, to figure out what's the area, okay, let's give it a blue color, so it will be different. You know, if I had to ask you what is the area between two curves, I think you're probably gonna guess right. I think it will be interesting to know that basically let's say let's call this f of x, and let's call that g of x. Okay. What we're going to do is find out the definite integral between these 2 points. We will have to figure out what they are. Okay, we'll call them a and b. Okay, we'll have to figure out what they are. But we're going to find the definite integral between a of b of what? Not of the integral of g, not of the integral of f, but rather the integral of g minus f. Would you have guessed that? Would you have guessed that? I don't know. I think maybe some of you would have. And before we start calculating, let's try and understand why it is. Okay? Maybe we can write it down as a statement. Okay? So area between two functions, area between two curves of f of x and g of x is equal to the indefinite integral of the difference between these two graph between these two curves. And I put the higher curve first. I'll put G at the top. Okay? Between the 2 points where they meet. Okay? Now, why is that? Think about it. What is this? Let's open it up a bit. That basically, we've got an integral of a difference of function. Now, we know that we have integral of a difference of function. That means I can do the difference of the integral function. So, in other words, it's indefinite integral of g of x minus dx minus the indefinite or the definite integral of f of x dx. Okay? So, it's basically doing the integral of this minus the integral of that. Now, why is that absolutely the right thing to do? Because what is the integral of g of x? Well, that is this area. Okay? That's area under g of x, or between, let's say to be more specific, it's area between g of x and x-axis. Okay? That's this area. And what is that integral? Okay, let's use a red one. What is the integral, the definite integral of f of x? That's the area, okay, area between f of x and x-axis. So what I would do, we calculate the whole area under this parabola, in this case, under g of x, minusing the area under f of x. What we end up with is obviously the area between the two curves. So that kind of intuitive and kind of makes sense, isn't it? So now what we got to do is just calculate it, okay? So let's carry on until I run out of space. So obviously we need to know what these A and B's are. So here we're doing just normal algebra, grade 10 algebra, okay? I'm just teaching my grade 10 this thing. How do you know these points of intersection? Well, this one is, well, let's just do it, okay? How do I know point of intersection? I'm just making sure that they are equal. So minus x plus 2 equals 6x minus 3x squared. So we'll move everything there. So it's going to be 3x squared minus 7x plus 2 equals 0. Okay, is that right? Okay, I don't know if you've seen, I mean, like, you can use the formula, okay, the minus b plus minus b square or b square, all that. Let's try, I'm hoping, I'm just going to pause, see that, not going to pause, but just quickly see if there's answers that are rational. The answer are rational. So I'm going to just try and do it. I don't know if you've seen it before. I'm going to try and trinormalize it, okay? The trinomials are more difficult when we have a number which is not 1. And what I've learned to do, which is quite cool, I think, is to split that minus 7 into two numbers. Let's say minus 4x minus 3x. And these two numbers, they obviously need to add up to minus 7. But when we multiply them, they need to be multiplied to the product of these two, to 6. So what will I use? What will I use that will add, multiply to, I got it right. I'm not doing a mistake here. No, I think I'm not doing a mistake. So two numbers that add up to minus 7, but multiply to 6. Ah, yes, of course. So it's going to be minus 6x minus x, okay? And then plus 2. So I'm just splitting that minus 7 into minus 6 minus x. They add up obviously to minus 7, and they multiply. Minus 6 times minus 1 is equal to 6, which is the same as 3 over 2. Now what do? We just, this is obviously equal to 0. Then I factorize. Okay, so I factorize this. This is going to be 3x, x minus 2. And then here I'm going to write, I've got x minus x plus 2. So I can write it as minus x minus 2 equals 0. So that's the first factorization. It was grouping really. And now factorize it again. X minus 2 times 3x minus 1 equal to 0. So that's just another way of factorizing these tricky trinomials. I don't know. It might not be the easiest way, but I kind of like it. I don't know why. So we've got two answers. The first one is x equal 2, and the other one is x a third. So that's obviously going to be a third, and that's going to be x equal 2. Okay? Now I'm just going to pause and make some space. Okay, so what I'm going to do now is just find the definite integral between x equals third to 2 of the difference between these functions. So it's going to be 6x minus 3x squared minus x plus 2. I got to put the function that is above first. Otherwise, I'll get a negative answer. Okay, so that's all dx. Okay, we're going to write it nicely. So I've got a third to 7x, right, that's plus x, 7x minus 3x squared minus 2 dx, okay? And then I'm going to just do the just integrate this, so it's going to be 7 over 2x squared minus x cubed. You see, I don't need to do anything with x cubed because the 3 jumps out. I just had to put that minus 2x, and I put in the boundary, a third edges, and 2. So what I got to write down is 7 over 2 squared minus 2 cubed minus 2 times 2 minus the same thing, but now put a third everywhere. 7 over 2, a third squared minus the third cube minus 2 thirds. Okay? And if I got it right, okay, I'm not going to do that if you don't mind. Okay? If I've got it all right, then I should get, according to the textbook, 125 divided by 54 units. I wasn't very careful before. If they told me these are units, then these will be units squared. Okay? So I'll just pause here and see if there's anything else that I've missed, and we'll say goodbye after that. Okay, so the only thing that I didn't really, that I've read in the book that they said is that to calculate this area, I can do the way I've done it. I can just do that minus that, okay? But you got to make sure you put, what you're minusing must be the function which is below the other graph. So that's one possibility. Or you can do what's written here. You can find out the area under this G. Find the area under the F with that integral. So two separate integrals, and then do one minus the other. The good thing about doing it this way is that you're never going to get a negative answer. So if I got, let's say, 100, and here I've got 70, then you know very well you're going to do 100 minus 70, so to get 30. Where here, maybe you made a mistake and you did that minus that, you'll get something a negative number. But anyway, you can go both ways. Have a lovely time. I will see you next week.